Okay, so I think it started. So just let me wait for a second, for a moment. Okay, it started. So hi guys, welcome to High Entropy, and it's day 55 of DSA learning, and we are going we are solving the dynamic programming problem or DP problem. So so far we have covered like mostly we have I tried to solve the knapsack problem or all of the problems that I have solved so far are mostly related to zero and knapsack. So let's see how things goes and let's see what are the different problems that oh okay. By the way, welcome to High Entropy. Just let me wait for a second for a moment. Okay, so today's agenda is simple. So today's agenda is simple. Our goal is we need to solve one problem with full focus because nowadays I'm feeling like I'm not focusing much on the problem. I'm just getting hallucinated and okay, I'm assuming like okay, this is the thing, and that's why I take more time. When you have your concepts are clear, it should take less time to code. So let's focus on it. And if the topic is completely new, because I watched the videos related to zero and knapsack, so I know how to solve them. So it should be like quicker, right, as per my expectation. So let's focus. And I think internet is very slow. I don't know if you will be able to see my stream or not. I think there will be so much lag if you will see. But no problem. We are here to show up every day and solve problems. I think links are not working, clicks are not working. What is the issue? No problem. So here we are in the DP on subsequences. Count partitions with given difference. Let's see what exactly it is. Okay. Given an array of n integers and an integer diff, count the number of ways to partition the array into two subsets x1 and s2 such that h1 minus s2 diff, okay, and equals to diff and h1 greater than equals to s2, where h1 and h2 are sum of subset 1 and subset 2 respectively. Great. Return the result. Count partitions with given difference. Okay. It's also similar to zero and knapsack. What I see. Suppose you wanted to divide if you wanted to divide the array into two subsets, then equal two subsets, then it will be like you are targeting something like okay, I'm using so many times like, so I have to avoid it. So the idea is simple. If you are dividing an array into two equal parts, then difference will be 0. But now we have to divide an array into such a way that the difference between them is the required difference. Can we say if one is s1 and then another will be s minus something? Got it? And we can find, if you can find this target, then you can get another part. So it's target problem. Find the target. If you can get target sum, all the counts. Let me tell you, explaining in a proper way. So our goal is simple. We have given s1, s2. Okay, let me note down example as well. 1, 1, 2, 3. Come on, bro. Okay, so this is. So let me note down all the things first. I'm just starting it quickly. Return the modulo 10 to the power 9 plus j1. Okay. A partition means that the union of, oh, let me see. Given an array of n integers and difference integer diff, count the number of ways to partition the array into two subsets S1 and S2 such that S1 minus S2 is equals to difference and S1 and sum of S2 respectively. A partition means that the union of S1 and S2 is the original array and no element is left out or used twice. Every element of the array belongs to exactly one of two subsets. Okay, got it? So everything is same kind of details are there. So we have S1, we have S2, and our goal is S1 minus S2. You can say is equals to diff. Okay, diff is given. So can I say if S1 greater than S2? Okay, that simply mean I will keep the same size. S1 greater than S2, it means what you are looking for. Simply you are looking for something. S1 is greater than S2, so S1 minus S2 is equals to D. That's the difference. So S1 is nothing but okay. So S1 plus S2 should be equals to S total sum. Okay, so you will say okay, let's add them. So if you add, if you add them, then it will be something like 2S1 equals to D plus S, S1, D plus S by 2, something strange I did. S2 plus D. Oh, it's strange. Okay, got it. Simple. Now our target is we need to find S1. Okay, if you are looking for S1, so it's not this problem converged to the simple problem where you need to find a target sum S1 in the array. If you can find it and you can count what are the different subsets where you can find target sum S1. Okay, and for the different subsets that you are getting to find the target sum S1, that means another sum will be S minus S1 and that will be nothing but S2. So you're getting fraction. That simply means you cannot divide it into S1 minus S2 and you can get this. So you can return 0. Else, if it is the possible, then try to find S1. What are the different ways or the different subsets from which you can get S1? And that's all. The whole story revolves around S1. So we can say it's like a target sum problem. Target count of subsets with target sum. So okay, so I'm just thinking like is there any possibility? So let's take example again. I forgot it. 1 1 2 3 1 1 2 3 and here D is equals to 1. So let's do it. So S1 will be nothing but D plus S2 S by 2, right? So total sum is S is nothing but 2 plus 2 4 3 7 7, D is 1. S1 will become 7 plus 1 by 2 4. S1 will be 4. Okay, 4. Got it. Now S1 is 4. So our goal is if we can find all the counts where 1 will be 4. So you can say okay, everything you took 1. Let's create a tree. Your target is 4. So at the starting you have 0. Now you are moving to first element and you have two options, either take. So if you take, then sum will be here. You are at here at the first element and you said okay, I'm taking it, then the sum will be 0 plus 1 1, and here if you are not taking then it will remain 0. Now you are moving to second element and you are deciding, so you will say okay, now I need to decide again. So you will say okay, let me take it again in the first condition where you are taking, so it will become 2, and if you are not taking it will remain 1. And for this branch you will say if you are taking 1, if you are not taking it will remain 0. Now again you will say at each step you will check if you are getting the sum h1, if you are getting h1 4, so you say okay, it's less than this, so we'll continue. Now you will jump into the third element 2 and you'll say okay, can I get it? So I mean, can I include it in the knapsack because our weight is 4, uh, capacity is 4, you can say. So okay, so it say like okay, if I will add, then it will be 2 plus 2 4, so you will say okay 4. And here you are not adding, then it will remain 2 only. Here you will say okay, I am adding 3. If not adding, it will remain 1. Same here, if you are adding 3, if not adding, it will remain 1, sorry. And here if you are adding, then it will become 2. If you will not add, then it will remain 0. And now the decision is at the third. So here you see you got the result, so you will return from it. From here you will see okay, if I add 2, then it will become 5. So from 5 you can say okay, this is not the right solution, so here you will return 0. And from here you can say if not adding, then it will remain 2. From here you will say, I mean adding just what do we say, it's like a little, okay, let me do one thing. I will add it, I keep it here. So god it's not working. So you will say okay, no problem, I will do something like this. Now it will be easy, space will be there, so write the proper way. So you'll say okay, no problem. Now for 3, take or not take. So if you'll take 3, it will become 6, that is also not possible. And if you will not take, then it will remain 3. For 1, again you will say if you are taking, then it will become 3 plus 1 4. Okay, if you will take, if you will not take, then it will remain 1. For here also you will say if you take, then it will become 4. If you will not take, it will become it will remain 3. For 1, if you will take, so sorry, I mean yeah, here I did mistake. So if you will consider, it is 3, right? So if you will consider, it will become 6, that is not possible. If you will consider it, it will become 4. If you will not consider, it will remain 3. Again 4, it will become 4. If you will not consider it, then it will remain 1, whatever we have. If you will consider, it will become 5. Not consider 2, so this is also not possible. Here you will see okay, if you will consider, then it will become what? Consider, then it will become 3, else it will remain 0. Now just see, now everything is finished, all the array. So from here you will say okay, I am getting 1. From here this is 1 count. From here you will say 0. From here also you will say 0, because everything is finished. Now you cannot move further, or you will move even, then it's like I equals to this, and then you can say okay, we cannot explore further, so it's like already covered. So if you say like okay, move to another step and see, so you from here 0 0 0 and here 1, so these are 2 options, and I can see, and here also 1, and all other are 0, so we can get 3. Oh, 3, see. Okay, now if you see, there are so many repetitions. Let's analyze it. Okay, you will see okay, you are repeating the same thing again and again. First thing, how can we memorize it? Thing is like, we need something. At each step we are looking for a target, so how many elements we have covered and what is remaining. So for example, right now we are at 0 and we are looking for target, some particular target. Okay, here you can say I'm at 0, I have 0, or you can say I'm looking for target. What is target? S1. S1 is 4. 0 comma 4 you will say. Here you will say okay I have 1, so it's like 0 comma 1 you will say. 3, I mean looking for 3. Here you will say 0 comma 4. Same you will see here 0 comma, now you have 2, so what you are looking for? Remaining part. So it's like you are looking for, okay I got this, now I'm looking for 2, 0 comma 2, and you will see so many places where it is same, like you have, I mean yeah, it will be 1, and here it will be 1, 2 at like 0, at you are at 0th position, and you are looking for weight 4, and it goes on. So that's how you can do it. Even I think I'm not able to visualize it properly. I don't know if I'm not wrong. Let me see. Okay, so here you will see, okay, I'm starting somewhere. So you will say, okay, I'm looking for 0. I'm at 0 position, and I'm looking for 4 target. Then again you will say, okay, I'm at this element and I'm looking for, so I have covered so far these many elements. So for example here you will say, okay, I'm at this location, I have covered first element, I already took or not took. Now I'm looking for 1 and 4. Can you get it? If you can get like from 1 onwards, so that's how you can do it. So what will be the solution for it? It is simple. You can say what we say, 0 in knapsack. So you will say function, and you will provide I, and I is nothing but the element that you are processing. So you will start from 0, first element, and here you will say, okay, I'm providing I, I'm providing n. Let's provide current. What is the current value? And you will provide n, or let's say target. Okay, so now it will be same as other problems, and target, current value and target value, and then array you are providing n, memory you are providing. If first condition, if current value became equals to target, that means this is a possible option, return 1. If, I mean it's not going to happen, so but still I'm writing it, I won't write it. So if I became greater than equals to n, that means you already covered all the elements, so now you cannot get. Okay, it's like you already explored all the items and you are unable to find it, so we'll say return 0. And third option, okay, I mean it's not needed. So and third one is, if you have something like in the memory, you can say I'm looking for current value, and right now I'm at the ith location and I'm looking for current. Is it possible to get greater than equals to 0? That means you got the result, you already pre-computed it. Return mem of I and current. Okay, other than that, if take, you will say simply take equals to 0 if current element is less than the required weight target. If you are adding current plus, you can say no, current plus array of the current element I less than equals to target, that means okay, it's okay, still you can feel it. So we'll say okay, take will be, now I need to check self. Okay, so let's say solve, what we kept, function, and we are going to pass some values in the sense, okay, function, and here you will move to next element I plus 1, your target will be, your current value will become current plus array of I, and target and all other values will remain same. Not take, not hot. It's a not take. That means you are doing something like a function. You are moving to another next element, and but still your value weight or the calculated current value will remain same. Target and all other stuff will remain same. Finally, you'll get result. Result will be something like not take plus take, whatever the result that you are getting, and mem of I and current will be equals to result, and return mem or even return result directly. Why do you need to? And these are the conditions, and at the starting you will initialize memorization memory, and you can do it. Yeah, that's all about this. I mean, we'll go through tabularization method. So let's do it. First thing, n we have given, so we do not need to recalculate it. S, I'm looking for sum of array, so we'll get the total sum of all the elements. S1 and S2 we need to calculate. Okay, so S1 or target, you can say target will be nothing but okay, so let's say target. Okay, what I'll do, remainder, let's go. Okay, I'm confused. What should I start? Remainder is nothing but target, not target, diff plus s by 2, percentage by 2, and let's say if rem not equals to 0, that means you are it's not valid option, you cannot get it anyhow, so because you cannot split it into two parts. Okay, else you will say okay, no problem, else target will be something like diff plus s by 2, and you can say return result self dot solve. I'm using solve method always, so here you will pass I as 0, and what is current value will be 0, and what is it else, I just wanted to use to current is 0, I equals to 0, so it will be easy for me to I current and n target called target, and then mem array mem. Okay, let's create memory. Mem is nothing but here simply it will be two-dimensional array where first thing is the size of, so what we can see, -1 for all the values are greater than this now. So okay, for I in a range what, so you are looking for S1 target, so target plus 1, okay, and now you will say for underscore in a range, and here you will say total n elements are there, so this is the size of it, and finally you are going to create function def solve self mem if I equals to, okay, if current value equals to target, that means you got the value, return 1, and if I greater than equals to n, that means you cannot get further, all the elements you have covered. Okay, so what you will say, okay, no problem, I got like return 0 if current or if mem of I and current, the target that you are expecting, that you have right now. Okay, so is greater than equals to 0. That means someone already processed it and written name of I and current. Okay, finally you will say, okay, if these are not the conditions, then take will be 0, and if current plus array of I, that the element current element if you are adding is less than equals to target, so you can say, okay, we can take it, else you cannot take it. So self dot solve, and you will say, okay, I will be I plus 1. You have to start from next element because you are already processing, so you have to go to the next step, and you will say 0, not 0. Current plus array of I. Okay, this is nothing but your current value, updated current value that you are looking for, and n will remain m, target will remain target, array will remain array, memory will remain memory. And not take, I will use the same not take, and here I plus 1. Only thing is it will remain this same, no changes in this. So result will be take plus not take, and finally what will the mem of I and current will become result and return result. Okay, so everything looks good. I'm wondering, like, target plus 1 memory. Okay. Mm-hmm. Current equals to target, that means we are not storing it right somewhere. I mean, we are not using it. So current target. I could be 0 target looking for. Okay, leave it. So how much time I spent so much so far? Let me see. Oh, 28 minutes. Oh, MZ. Let's see if everything looks good. For me, look, it looks good. I'm so sorry. Again, I did the same blunder. Marlo, who will take Marlo, bro? Everything looks good here so far. Only the problem is result. Percentage by mod is nothing but 10 to the power 7 or 9. Oh, God. I'm just thinking, like, Expected 8. Oh man, the element can be 0. And now, missed the corner cases. Not still making the same mistake. Okay, let's see what are the different options if we are going to do it. Okay, so here we'll say no problem. So 0, what are the different options I can say? 0 minus 0, 0. Total S equals to 0, and S1 will be 0 plus 0 by 2, 0. Target you can get 0. So you will start with at starting 0. Okay, let's try it and we'll solve it. What is the problem exactly right now? So where you have 0 right now at starting, assume nothing you haven't taken. Now you will start with this element. So you'll say, can I take it? If I'll add it, what will be the result? You will say okay. If I'll add it, it will be 0. If I won't add it, it will be 0. You can say good. Now I'm just thinking, what are the different options? Whenever you are getting target, okay, you still have to explore other options. Suppose here you got target, here you got target, so you won't start returning from here and from here. Is the problem? And starting only in the first call only it will return 1, and that's why. So what we need to do, when we are getting some value, target value, and we passing it at each line, you are saying okay, if you got the target, before even exploring you will say return 1. But what needs to be done, little modification is required in this condition. Okay, you have two options, let's say. Now you will say okay, no problem, I can look for other options, can I still get this value? So you will say okay, no problem, I have considered it and I will consider it again. I will not consider it again, so it will be 0. Then you will say okay, no problem, like you considered first element, you considered second element, here also you are considering, then it will be this, you are considering, then it will be this. Now you are going back to next element and you will say okay, if I will get it, if I won't get it, this is the condition. And here you will say okay, I'm getting 0, I'm getting 0, I'm getting 0, I'm getting 0. So that's why you are getting 8 from all the counts. So earlier what we used to do, whenever we were getting value, this time right now 9:23, written directly matching value, getting target value. But now the thing is that can I say something like if current plus the element that I'm going to add area of I is less than 0, I mean it is equals to target, and less than equals to target. Target, just explore further. Yeah, so here the thing is simple. I need to modify the logic. Right now we are returning at starting current equals to target. If matched, we are returning 1. So one thing I need to change here, we need to make a decision. If next element is 0, that means we can consider that element as well in the bucket. And you have two options whether you are considering or not considering, so you can get. So if current plus okay, I think I need to take two decisions here. If current equals to target, if I equals to n minus 1, that means you already covered all the elements. Then okay, so let's say if current equals to target, simply there are few decisions that I need. If I equals to n minus 1, return 1. That means you cannot get further, you cannot explore further. So that is okay. That is one condition. If I, that means if it is not the case, let's do it like this. If I greater than equals to n minus 1, return 1. That means if it is not the case, that means you need to check current plus area of I, whatever the value right now you have. So you are going to explore is less than equals to target, then you will explore, you will continue, not continue. Okay, so here we say is greater than target, or let's say not equals to target simply. That means return when, else you have to explore further options. So yeah, I think this should work. I'm just trying hacky approach or what? Not hacky approach, but it seems like hacking. Okay, so. Here, not here. Current equals to target. Then, if I less than greater than equals to n minus 1, simply return 1. If current plus area of I, that means I is less than equals to less than n minus 1, I area of I, if add is less than is not equals to target, that means you cannot get it if you add this element, and you are already covering that take not take. So return 1. Else simply do whatever you wanted to do here. But bro, will it satisfy all the conditions? If I'm not wrong. And I'm asking, I'm just solving. Oh what, it again failed. Your output 4, expected 8. No. Okay, I haven't used this test case or what? What the heck, bro? Four. How? I equals to n minus 1. That means you are processing the last element. Last element you haven't processed, so you. Yeah, that was the case. Let's see now. But if I'll use tabular method, how much time I took to solve this? I'm making mistakes. Solved, but not bad, not good. I appreciate, but still it's not good. Yeah. I mean, I can't be too harsh with me. Wait. Now let's think about the tabular method. That is the. No, I don't think that will be hard part now to solve because we already solved it. Just we need to tackle base conditions properly. Zero, 1, 2 up to you can set target, and here 0, 1, 2 that is n minus 1, not n minus 1, n. Let's see. I'm a little scared. I don't know why. I think I will create some mess. Okay, no problem. Mess, we are learning here. Yeah, what did? Is anyone watching my stream? Just wanted to, just curious to know. I don't think anyone is gonna watch. But if you are watching, just sort out. And yeah, looking. I think the problem is no one is watching. I'm a little scared. I don't know why. Oh, I think I will create some mess. Okay, no problem. Mess, we are learning here. Yeah. Bro, don't be so excited. Okay, so now our goal is like if we are looking for target 0, we have 0 elements. Then it will be 1. Okay, it's possible, right? If we are looking for target 1 and we have 0 element, then it's not possible. We will say 0. Looking for 2, 0, 0, 0, 0, 0. Now you are looking for something like this. Okay, bro, you will say what? You are looking for, you have, your target is looking for target 0, 0, right? And how many elements you have? 1. Can I fill this base condition? I don't think it will be possible to fill because it's dynamic, right? So okay, it's like you are looking for, you have 1 element and your target is you are looking for 0. You can say okay, like you have 1 element and you are looking for 0, so this will be 1. But what about if you have 2 elements and you are looking for 0? So earlier we used to say 2 elements. If we do not have 0, then you will say okay, this is one condition, you are not taking anything. But now elements are 0, so you will say okay, you have 2 zeros and now you are taking. So first condition is you are not taking anything. So let's start with first. So at the starting you have 0, you started with 0, you took the 0, you haven't took the 0, still 0, you took the 0 and you haven't took the 0, you took the 0, you haven't took the 0. So total 4. So it all depends on the number of elements that you have. So we need to calculate it. I mean, we cannot guess it directly. So you can say if you are at I and Z and your target is Z and you are looking for a result, then you will say you have two conditions. Either consider it or not consider it. So take and not take. Right. Now in case of take, in case of you are not taking it, then you will say simply okay, no problem, I'm looking for Z target. So you will say table, give me table, this element is not taken, so I minus 1, the number of elements you have, and you are looking for target table, target 0, say. So you will say okay, whatever you are getting from it. In the take, there will be two conditions. If you will say if take, I mean so take will be having two conditions. If you are adding j, if current element, or you can say what is the array of I minus 1 is less than equals to z, that means you can take this element. Okay, so you will say no problem, I'm looking for this element. So you'll say table of I minus 1 and z will remain z minus array of I minus 1. So you said, okay, I'm considering this element table. I minus 1 means first element. So I'm taking this element, and you consider this element I minus 1 previous. What are the result for it? And then you will say, okay, taking, if it's less than, then whatever result that you are getting, you will say plus. It's same, right? Only you won't feel it. So let's do it. I mean, I just wanted to see it if it is working. So let's say we have 0 0 0. Okay, at starting we have this condition. Now we have one element. So what you will say? I just need to memorize it a bit. Okay, so 0 previous row you are going to check, and c minus 0. So it is 0, then that means you will say, okay, no problem, this plus this will be 2. Okay, you will say, okay, no problem, it will be 2. And here you are looking for 0, right? So there won't be more than 0. So target is 0, diff is 0, and your SO is 0. So you are going to handle with this condition only, this one. Now you will say, okay, here I am right now. So you will say adding this element is less than 0. So okay, you can say, okay, let me take it and z minus a. So you will say 2 plus 2, 4 will be here. Then again 4 plus 4, 8 will be here. So yeah, it will work. Perfect. Just I need to, here just one condition we made change, and that is table. We need to create table. Okay, let's do one thing. Target if, okay, let's do one thing. So if we have S will be sum of array and D. So okay, so remember, not remember, remainder, not reminder. Remainder will be, what is time right now? 9:40. So S plus D diff percentage by 2. If rem is rem not equals to 0. What is that? What does it mean? It means you are getting fractional value, so it's not possible. Return 0. Else you will say, okay, no, I don't need to take else. Table, you will say table. Table will be, here you are going to create table. Okay, one thing we need to, okay, table, target will be S plus diff by 2. Okay, now we need to create table. So why do we need to create tables? You can say previous will be like previous and current, we can deal with it. So here you will say -1 for underscore in range target plus 1. Okay, and current, it's just placeholder, we are not using. Here we need to, okay,